Good afternoon, everyone. My name is Katrina Bob-Cusworth. I'm the Communications and Events Coordinator at the Melbourne Energy Institute. Thank you all for joining us today for the second installment of this year's MEInetwork Seminar Series on gas supply chains. Before we begin, I'd like to acknowledge that today we're speaking from the lands of the Wurundjeri, Woiwurrung and Boonwurrung people who've been custodians of this land for thousands of years. And we acknowledge and pay our respects to their elders past, present and emerging. For our online audience, we invite you to acknowledge the country you're tuning in. For those online, if you have any questions for our speaker today, please enter them into the Q&A function in Zoom rather than the chat box, and our moderator will follow up with you as well as with those in the room. So now over to our moderator, Dr Adrian Panow, Director of Major Projects at
Thank you, Katrina, and welcome to everybody in the room and online. Thank you for joining us for the second seminar in this series, and we look forward to participating today and the months to come. The basis for the seminars is really that if we are going to be undergoing a transition, we need to understand the system in which we're operating, how it actually works. And that has been a feature of this political landscape a lot, but there is a lot of commentary with little understanding of the complexity of the system. And we're trying to really address that issue through a series of seminars. Even today, we couldn't have picked a more topical or more appropriate time for this topic. And I've just opened up the Age page, and if you go to that, 2 out of the 3 top stories. First one's gas reserves for eastern states are complex by the minister, so at least we have that honesty. Then there's a story about Elon Musk walking away from Twitter, and then the third one is it just made sense. Want to save $1,859 a year to ditch gas, and you have that enormous range of issues with gas alone. We're very fortunate today to have Matthew Clemow with us from AEMO to describe some of that complexity. So Matthew is the Group Manager for Gas Operations at the Australian Energy Market Operator, AEMO, and has worked in AEMO for 9 years, both current role and as so there's both positions within the organisation, but also the complex environment in which it's responsible. He spent a decade prior to Energy Australia, as well as a number of years before that in Singapore. Rather than prolonging the introduction, which I'm sure if necessary, Matthew can go into some of that detail, I'd certainly like to welcome Matthew and thank him for presenting today.
Turn this thing on. Is it working? Excellent. Afternoon, everyone. As the introduction said, I'm Matthew Clemow from AEMO. There is a lot of complexity in the gas system and the gas markets, and we're going to try and distill this down into a couple of bite-sized chunks. So what we'll do in the first part of the presentation is actually just run through AEMO's gas markets and okay, what are the aspects of the gas markets, but also one of the aspects of any market is supply and demand. So we'll actually run through a bit about gas planning, what is the gas supply shortfall we're talking about, and some of the supply projects that are being talked about. And in the second part, and again, this is fairly integral to the operation of the markets. In Victoria, AEMO's got quite a unique role where we are the market operator, but we are the system operator. And there's a number of reasons why that's necessary, and we'll sort of run that through as well. So also, I'll just apologise in advance. My voice is not really great, so you might have to attack the water every so often. So in terms of AEMO's roles, basically AEMO came about in 2009. And prior to that, there was a bunch of state-based market bodies. And then in 2015, AEMO, West Australia was added in. In terms of ownership structure, we are sort of a statutory body we've got a number of ring-fenced functions with 60% owned by government and 40% owned by basic industry members, which is pretty much the retailers. In electricity, we operate the electricity markets and we manage a lot of the electricity planning. We also obviously manage connections to the power system. So all the new wind farms, solar farms, all the new interconnectors, AEMO has to manage those connection processes. And in gas, we operate the markets, obviously. We have gas bulletin board, and again, we have planning functions. And obviously, who pays our bills? Most of our revenue comes from market fees, and I'll cover that through. In terms of where AEMO fits in the system, you know, I was even, I think, on the ABC News the last couple of nights ago, oh, the regulator's done this. It's like, no, we're the market operator. We've capped the price, or we've done X, Y, Z. In terms of running from the top, you know, you've got the government stakeholders, members. So you've got the state and federal energy ministers. That used to be the COAG Energy Council, but now everything's a national cabinet. So it's the Energy National Cabinet Reform Committee, and there's other bodies sort of underneath that. And we also have the Energy Security Board, which is sort of looking more predominantly at the power system at the moment, but you know, looking at the whole of system design. And then we run through to the Australian Energy Market Commission, that actually is the market advisor and is the one that actually makes the rules. And then we've got the AER, that, you know, the Australian Energy Regulator, that actually monitors enforcement, monitors conduct, monitors compliance with the rules and conduct, but is also the economic regulator for covered monopoly assets. So they'll actually determine how much the monopoly assets get paid. And then we're down the, you know, bottom of the, sorry, it's moved by itself. We're down the sort of the bottom there. We're actually operating the markets and administering markets and the procedure, and we develop procedures to make the rules work. In terms of the gas markets in Australia, you know, in Eastern Australia, pretty much most of Eastern Australia is covered by the national electricity market, one single market. In gas, it's actually a lot more piecemeal, and that therefore makes it a fair bit more complicated. And we'll run through each of these markets in a little bit more detail. But you have the Victorian market, you have the short-term trading markets, the gas supply hubs, pipeline capacity trading auctions, and then the retail markets. And then you've also, in Western Australia, just to be completely different, there is actually no AEMO markets over there. And that part of that feature of that is that Western Australia has only sort of been part of AEMO since 2019. 2019, let's say 2015 anyway. In terms of how the markets function, I mean, really it's like any marketplace. You've got suppliers and buyers, energy's offered into the market, people want to buy energy from the market, you know, people get paid for gas into the market and out of the market. There's also services, right? So in gas, and particularly in the Victorian system, we have ancillary services where gas is supplied to keep the pressure in the system. So that's a service, and those services then have to be funded. And obviously, as I mentioned, to actually pay for AEMO, then there's fees on all of those transactions just to pay for me. One of the other things, obviously, Market 101 is at a very high level, how's price set, right? I mean, you know, so what most of the markets have is we actually basically have a bid stack where gas is bid into the market at different prices, different quantities. And, you know, that'll be a typical bid stack. I mean, at the moment, those numbers aren't right. They should have 3s and 4s in front of them, but, and not the good old days when it was $3 and $4. But yeah, anyway, you've got a bid stack of, say, over 600 terajoules there. And the demand forecast, or the demand for gas in that market, is 550. So the price will get set at $9.32. Everybody who was scheduled, you know, below that price all gets paid $9.32 for the gas. There are some markets where it is price is bid, but generally in the pool markets, everybody gets that $9.32. Okay, so let's do a bit of a run through of our markets. We'll start off with the short-term trading market. There's actually three of them. Sydney, Adelaide and Brisbane hub. They started in 2010. They're designed to provide transparency in that location of a gas price. All the gas flowing through the SCTM is part of the market, which means subject to the fee. Participants can choose whether or not they're going to buy or sell gas from the market. Probably the Sydney market's the most liquid of the three. It does have the sort of generally the higher throughput of 200, 300, 400 terajoules a day, whereas the other markets tend to be a bit smaller. There is generally a lot of buying on those markets. They all generally operate the same rules. In terms of responsibilities, AEMO operates the market, and there's also a process called contingency gas, where in the event of a shortfall, AEMO will there is another stack of gas which is not normally available, and that can be scheduled in. That can be where people agree to turn off or agree to offer gas in the market that's not normally offered. In terms of the market participants, it's their responsibility to actually be able to get the gas to the market. So they contract gas on the pipelines, and then they forecast their demand, and then they'll nominate the gas to the pipeline operators, all the storage providers in the hub. So the Sydney market has a LNG facility, so that gas can also be scheduled into the market. And then you've got the service providers. So the service providers are responsible for actually following the schedule, and also providing the flow information to AEMO, so the allocations, and then you've got effectively the network operators responsible for emergency responses. So in terms of a typical day timeline, the market schedules are about 12:30 in the afternoon. Then the market participants then make their bids, their nominations to the pipeline operators. The gas will then flow the next day. If there is intraday movements of gas flows, that's handled by a process called market operator service. So that's moving the line pack, the pressures in the pipelines to actually supply the additional gas or variations in gas flow through the day. And then at the end of the day, the next day, then there's a schedule that divvies up the unders and overs for the day. Next market, is what we call the gas supply hub. So this is a voluntary market, and this is really the point where the market accesses Queensland export gas. So if I won't say gas of last resort, but if it's where there is a need for additional gas that's not otherwise bid into the market, then that gas can be sourced from the gas supply hub. We do see during winter and summer periods, particularly when there's a lot of gas generation in, or there is a period of high demand or an outage, we see an increase in activity on the supply hub. It's an electronic trading platform where there's basically bid and offer like any market trading portal, and there's a variety of products that can be traded. As I mentioned, one of the key things with the gas supply hub, it is access to effectively the international market. So effectively those prices are at netback, which is an ACCC number that they generate. So this is actually a graph from the ACCC's website, which shows, I suppose, until recently prices bounced around that sort of $6 to $10 range, and then obviously in the last 6 months, 9 months, the prices have been very high. With initially with the gas shortages in UK and the Northern Hemisphere winter, and then more obviously more recently with the Ukraine issues. Getting towards the end of types of market. Now, next type of market we've got is what we call this is pipeline trading. So this is not actually now buying and selling gas. This is actually trading gas capacity. So there's two mechanisms for trading gas capacity. One is the capacity trading platform, where I have a contract with a pipeliner. I don't need that capacity. I can trade that capacity to somebody else. and that's through the capacity trading platform. The other process which is available, which is probably used more often, is what's called the day-ahead auction. So that's when there's pipeline capacity that's not being used and it's not nominated, then the pipeline operator needs to then offer that for auction, and then participants can then bid to use that pipeline capacity. That then gets allocated, and then the shippers can then bid to flow gas on those pipelines. Lastly, in terms of markets, we've got the Victorian declared wholesale gas market. It's actually the oldest gas market, dates back to 1999. It actually covers the whole state, not just a capital city hub. So it is quite a different design. Obviously, being from Melbourne, everybody in the room at least, you know, there is a lot of gas demand in Victoria. We've got the highest residential gas demand in Australia, basically about 2 million customers. And there's also within the market, you have small customers, then you have large customers, about 800 large customers called tariff D customers, 800 terajoules a year, and you know, can have quite high gas demands in the system. In terms of roles, as I mentioned before, AEMO is the market and the system operator. So AEMO does have some emergency management roles and responsibilities. We also do produce a planning report for the Victorian system to actually look at the adequacy of the supply and demand balance in the system. With the market participants, it's their responsibility to still contract gas supply from supply sources. So that's obviously mainly the producers, but also storage providers, or from interstate that would then be supplied into the pipeline through the interconnected pipelines. The market participants have to forecast their demand, and then they need to inject their gas into the system in accordance with the AEMO schedule. In terms of the participants in the system, you have the DTS owner, so that's the owner of the system, so it's APA Group. We'll sort of cover a little bit more discussion about you know, the Victorian pipeline system. As I said, you have production facilities, storage facilities, and so on. One of the last ones probably on the list is just allocation agents. So that's where people actually need to determine how much gas is actually flowing from each facility into the market. So that's part of the accounting process. In terms of the VIC market, as I mentioned, with the short-term trading market, it's scheduled at, you know, by 12:30 the day before. It's all done and dusted, you know, and there's a little bit of variation. With the Victorian system, and again, I'll go into a bit more detail on why, but you know, if you tried to schedule the Victorian demand at 12:30 the next day, you just wouldn't hold. There's too much changes occurring in the system because of the weather, but also just changes in flows in and out of the system, and with the power generation. There's a lot of power generation in the Victorian system. Whereas with the short-term trading markets, most of the power generation is outside of the market. So at 6 o'clock in the morning, all the gas for the day trades. So it's the same as any other market. But then every 4 hours after that, there's effectively a reschedule where under or over deliveries are taken into account, or under or over demand is taken into account, or change of mind is taken into account, where, you know, people actually want to ship their gas in different directions. Now they want to take more gas out of the market or bring it in from somewhere else. As part of planning for the operation system, we also do day ahead and 2 day ahead schedules. And probably just on that last point, we also have a process which is called an ad hoc schedule, and I'll cover that off as well. The second part, where you know, if there's a threat to system security, you know, there are times when we can't wait for 4 hours to do the next schedule. I suppose just to summarize up then the markets, you've got the DWGM. It's a mandatory gross market maximum price of $800. I think there's been a little bit of media to say the underlying price has actually been $800 on and off last week or so with the gas supply issues. You've got the short-term trading markets. They've got a $400 max price. We have seen some couple of underlying $400 prices in the Sydney market as well for the same supply reasons. For the gas supply hub, That's a voluntary market. There is no real maximum minimum price, as I said here. It's just some of these numbers are in for just for error prevention, and the day ahead auction and the pipeline capacity trading prices are there as well. And again, they're just voluntary limits. So that's a bit of a market overview. I'm just going to take a water break. Right, we'll do a little bit of a discussion. So one of the things obviously is we're talking about markets. One of the key things on gas market is, you know, how people get paid and actually how much you work out the gas is flowing. One of the things with natural gas, it is actually sold on the basis of volume and flow and pressure. Gas is sold on an energy basis, not on a litre basis like petrol, right? So you actually take into account the energy that's in the natural gas, and different sources of natural gas have actually got different heating values. And as an example, you know, gas from the Longford gas plant, because of bringing in gas from multiple fields from offshore, their heating value can range quite a bit. Whereas the gas we get in from Coal Cairns, so that's the north of the state through the interconnector, we actually see a couple of different composition spikes on that gas that comes in. When there's a lot of coal seam methane in the gas coming from Queensland, you'll get that sort of peak off to the left, whereas otherwise we'll get the peak off to the right where it's more the gas from the Moomba gas plant. And then we also get the gas from Port Campbell, predominantly Iona, where it's again more of a single, I won't say single source of gas, but the fields are all very similar. It's all fairly light gas. So it generally sort of sits in that middle range there. So what's the heating value? You know, I've got a bill based on that heating value. So the Victorian system, lots of gas coming in from the southwest, and I'll run through a bit more of an overview of the system itself later. But we basically get gas from Port Campbell at the left-hand side. We get gas from Longford and the Bass Strait on the right-hand side, and up the top, this is gas coming in and out from New South Wales. So we've got, you know, pipelines that can run in either direction. We've got 10 injection points, 6 points where gas can be taken out of the system. And we've got 170 custody points that go into distribution networks. And we've really only got measurement devices with gas chromatographs that are actually measuring the composition of gas generally at those injection points and a few other points in the system. So we don't know at Bendigo what the heating value is. So in terms of options, you know, you could install gas chromatographs everywhere, or you could have a bunch of people doing modelling. You could try and break it into zones. All those are fairly costly. So what we did is we actually developed an online real-time modelling system that'll actually take the measurements from the field of what the flows are and pressures and temperatures, and they all come into the SCADA system. So this is telling us what the system's doing right now. We'll then feed those flows and real conditions into the heating value model. The heating value model will then take into account what's actually occurring in the system and where it believes the gas flows are going. So that's part of the SCADA data. And then once the system works out what the heating value is of the gas as it moves and mixes through the system, it'll come back into the SCADA system. It'll send that signal down to the RTU, which is the metering equipment, and it'll then tell the meters to use this number. And so for the next hour, it'll use that composition to meter the gas, and then that data will then come back into the SCADA system, and then into the database, and then into the production database, which is used for metering. One of the other things we do, probably just as a very high level point, part of the composition of gas we're measuring, we're also just making sure that the gas is actually safe and within specification. So there's parameters in their gas in terms of the heating value, some of the contaminants like sulfur compounds, and also an item called the WOBI index, which actually impacts flame stability. All that has to be monitored and kept within specs for safe use of gas. And AEMO develops specifications and guidelines for that, but it's based on the Australian standards. All right. Lastly, in terms of markets, we sort of did say we're going to talk a bit about gas retail markets or gas retailing. And as I said, I'm not a retailer. I'm not going to talk to you about customer acquisition and you know, how many magazine subscriptions or pay on time discounts you're going to get. But one of AEMO's really important core functions is actually making that competitive retail market work, and also you know, you think about your gas meter outside of your house, that's measured every 2 months, and via you know, magic, that is somehow translated backwards and forwards to an hourly settled value in the gas market that's then billed to each participant. So, you know, there's a bit of magic that goes on in the background on that. So that's effectively one of AEMO's key processes in the retail and settlement area. So all of the licensed retailers, you know, are part of the AEMO retail gas market in each of the states and territories. So there's around 5 million gas customers, and you know, effectively the market allows those customers to you know, choose who their supplier is. And those retail markets are operated in accordance with, you know, procedures and rules, like all the other markets are as well. So basically 4 key processes that we have. One is delivery point management. So this is actually transferring customers between retailers and going, well, you know, that's that meter number that's now being transferred to this retailer as opposed to that retailer, making sure all the data is collected. As I mentioned, the other key point is the balancing and allocation. So that really is determining how much of those 2 monthly meter reads that everybody gets, unless it's a tariff D site, which is metered every hour, but generally all the, you know, 2 million meters apart from 800 of them in Victoria are measured every 2 months. And effectively that's the calculation that runs through for that. We then obviously manage the procedures for those retail markets. And obviously we have the IT system actually facilitates all that. And finally, one of the things that's actually been in the news a little bit, obviously we've had some retailers not manage and survive the high prices. So there is a process called retailer of last resort. So if you're you know, gas or electricity retailer goes out of business, you know, there's a practicality of you know, nobody's come around and turned off your gas, so now somebody's liable to be on the hook for supplying you. But also similarly, you don't want your gas cut off because, you know, that magazine subscription didn't really come with a, you know, any sort of solvency of the retailer. So you know, there is a process and it varies by state, but in Victoria, the retailer last resort process is actually managed by the Essential Services Commission, and it is actually listed on their website of you know, who the default retailers are for Victoria. So depending on the distribution network, it'll be AGL, Energy Australia, Origin will actually become your retailer if your chosen retailer is no longer in business. Outside of Victoria, there's a similar process generally managed by the AER, the energy regulator, and they will transfer the retailers across, but generally outside of Victoria, it's AGL or Origin that have got most of the retailer of last resort obligations. I know there's a presentation coming on hydrogen, so there is one very quick discussion on hydrogen, because and it's really just how it would then interrelate with the retail markets. So one of the challenges in Victoria in particular is Victoria does run at the moment on what's called a statewide heating value. So despite all the little graphs and lines that I just showed you, there is actually an assumption and procedures and in the code that says everybody in Victoria gets the same heating value. That is something that's obviously being looked at. There's a challenge if you then start putting hydrogen in the system, noting that there is actually small hydrogen blending projects already running in Sydney and Adelaide, and a fairly large project proposed for Albury-Wodonga, is hydrogen's got a lot more heating value per kilogram of gas or of the molecule. But the problem is it's also very low density, right? And obviously, gases behave based on density, not on weight. So you actually then, if you've got a blend of 10% hydrogen, you've actually got less kilograms, and so you've actually got less heating value. And 10% blend would actually depress the heating value by about 8%. So that does actually require then some changes to heating value calculations and retail market system changes to actually accommodate that. And obviously the retail market procedures and the distribution code needs updating. And finally, one of the last challenges, and this is the last point on this one, is the actual Victorian market doesn't recognise supply into distribution networks. It just assumes it's a one-way flow. There's no supply into that. So if I want to actually be a market participant and supply gas into that point, that's not going to be recognised. So that's part one. Oh no, sorry. I've got a quick one on planning. Sorry. Okay, very, very quick to roll out planning in terms of gas supply outlooks. Obviously, Melbourne Energy Institute, there's a lot of discussion around reducing gas use, save money by stopping gas use. And a lot of the forecasts in terms of speed of transition is how much gas actually gets not used in future. And it's really just the speed of transition of maybe how fast the gas demand drops away. The flip side is, and this is in the gas statement of opportunities this year, is with increasing electrification, we're also likely to see increases in the amount of gas generation required to fill the gaps when the renewables outputs are low until storage becomes more mature and there's more interconnectors. So in particular, the green triangles, that shows the increase of the amount of gas use for power generation in the winter. The problem is with gas power generation in the winter is that's also when the gas system's generally supporting a lot of heating demand already, but obviously if you can electrify that, that comes away, but doesn't necessarily solve the problem because you're then potentially running power generation not all the time, but when there is no low wind and solar, then you're going to have a lot of gas demand in the system. So really that then comes into a bit of discussion of you actually still need capacity in the gas system for some time, not so much if you're not going to be supporting heating demand anymore, but to support the electricity demand, to support the heating demand when there's low renewables output. The other part of the shortfall is that gas production is forecast to reduce. So we're actually in this challenge of going, okay, we're not going to use so much gas, but the production's dropping away pretty quickly. There's not going to be no gas in Bass Strait, but the annual production is dropping away. They are projecting that SO's been in the media to say that this year will be their highest production in 5 years, but they're still a long way off that 5 years ago production. Probably the other point to note is we are actually getting a little bit more gas production in the Port Campbell area. So with the higher prices, that actually has encouraged a bit more production at Port Campbell from the Otway gas plant and the Athena gas plant, which is the old Minerva plant, which is restarted. to start processing some of the offshore casino Henry Netherby gas. And again, that's annual production. So it's all very good to talk about annual production. But one of the key points here is then it's all about peak day, right? I mean, so on a cold winter day, you've actually got the capacity to supply the molecules on the day. And probably a couple of key points to look at it on this graph is from 22 to 23, you look at the red line and the drop down in that. So that's the reduction in Gippsland production, which is mainly Longford. And then the other key point to note is you've got the purple line and you've got the left-hand purple line, which is the amount of supply capacity available at Port Campbell. But then you've got the right-hand line, which is the amount that can actually be supplied into Victoria because the pipeline is not big enough. And when you're actually sort of taking it outside of Victoria, we're actually then looking at a combined area for New South Wales and Victoria, where we've got constrained supply, where you've got production inside the box and storage inside the box. But then really the only two ways to get gas into that system is either from the Moomba Sydney pipeline to bring gas into Queensland, or you've got the Port Campbell gas, including the storage. And what we're sort of projecting, and again, this is sort of covered in the gas statement of opportunities, is where you then get some peak days. And if you look along the top here, you basically see the red line, which is the total supply, and you can see the drop down into 23. And you can see the seasonal demands and the purple. And then with the yellow, that's the spikes that we get in the gas generation demand. And you can sort of see in the blowouts, you know, spikes where you can actually get the total demand and the gas generation demand coming above total supply. And that's before you get unplanned outages, or, you know, I think those sort of figures are saying at the moment 25% of the coal fleet's offline at the moment. So, you know, it does make assumptions about how much generation capacity available and how much gas supply is available. So when we're then saying we're running out of gas, it's those peaks are going to become painful, or the generators are going to have to run diesel, or, you know, we're just going to see very high prices because there's just not enough supply. So in terms of how we fix this, there's actually a couple of projects that are in play. One project is should be commencing construction soon. It's called the Western Outer Ring Main project. It actually runs around the top of Melbourne, the northwest of Melbourne, and that actually enables us to join that high pressure gas from Port Campbell, which at the moment gets to, you know, the Brooklyn Altona area in Melbourne, and it stops. It's basically a choke point. It can't go any further. You know, that gas actually, you know, it's limited on how much gas can come out of that at that end choke point of the system. And having that connection around the outside of Melbourne actually allows a lot more to flow. It actually gives us some system security benefits as well. One of the things, and again, we've reported in our planning report, is from the end of next year, the Longford plant actually wants to take a whole day outage. Now, normally that's a full-on emergency. No gas from Longford is crap, all right? We just can't, the system won't manage that. Our actual current market clearing engine wouldn't actually solve for that. It's you know, we do need that security benefit of the gas coming around the outside of the system. On top of that, and as I mentioned, because with the purple, with those purple graphs that I mentioned to you before, we can't get enough gas from Port Campbell. So you know, the other option is to put more compressors onto a pipeline to actually send more up to Melbourne. There was a couple of options in play. What's actually been decided is already an existing compressor station at Winchelsea. By putting in another compressor there, it's more power, we can push more gas through the system. Another option is to actually build a couple more compressor stations, but that's obviously a lot more expensive. And while it does give you more capacity, you know, there's a cost benefit trade-off as well. What's been committed and has been recently announced is that APA will put a second compressor in, and the objective is to have that on for next year as well. The other thing I noted is if you go back to the yellow blob line, blob drawing or whatever you want to call it, where I said, look, the other way to get more gas in the system is through the Moomba Sydney pipeline, right? So APA have published, a stage expansion plan, which could increase the gas supply from Queensland. They have already committed about this time last year, May last year, to a first stage expansion of their pipelines, noting that that first stage expansion only added 30 terajoules a day to the Moomba Sydney pipeline capacity. So that'll be on for next year, but it's not a big increase. It does increase the Southwest Queensland pipeline a lot, but not so much the Moomba Sydney pipeline. Very recently, basically last week, now APA have announced that they will then expand those pipelines further, and that's with their stage 2 expansion. That does add a lot to the Moomba Sydney pipeline, and that's from winter 24. So that's, again, the market is responding to bring in more capacity from Queensland to keep the supplies up. The alternative, which has been bouncing around, is an import terminal. So everybody talks a bit about import terminals, and I'll cover off that in a little bit. But there's lots of import terminals being proposed. I think there's about 5. The AGL one at Crib Point was refused planning permission about a year ago. But Port Campbell looks to be the most favourable at the moment. There was actually a report recently to say that the Viva one for the Geelong refinery, they've lost access to their boat, their floating storage unit. So that's the boat that sits here. I think it's been contracted to Europe. And that's part of the challenge of these projects is, look, they're generally pretty quick and easy to set up, except, you've got an LNG tanker sitting there that's, it's pretty expensive rent. They carry gas at minus 160 degrees, a lot of stainless steel, lots of engineering. They're not cheap equipment. But one of the advantages of these systems is they are quite high capacity, so 500 to 700 terajoules a day capacity. If it was located on the Eastern Gas Pipeline, that pipeline flows 350 terajoules a day of capacity. So it is foreseeable and feasible that it could flow, 300 terajoules a day in each direction. So 300 to Victoria and 300 to New South Wales. So, and it can do it one day and then stop, another day and stop. One of the challenges, though, is you've got to match that with when the next ship's coming, right? Because the LNG tankers are all fairly contracted, but so there's a little bit of planning and inventory management, but coupled with other underground storages and other supply flexibility, it's still potentially doable, but still a fair chunk of cash, and you do need that big increase in demand that'll support that. And so that maybe won't come in until there's a lot more peaking power generation. So if we go back to that graph with the green triangles on, that shows the big increase in winter power generation. Once you start getting into those big peaks in winter power generation, that's when you potentially start building a business case potentially for an import terminal. One of the other ones too is, well, why import terminals? Why not pipelines, right? But if you think about a pipeline, the longer it is, the more expensive it is, right? It's a fairly linear relationship. Whereas with and that's effectively the blue/black lines on the graph. Whereas with a import terminal, once you actually got the gas liquefied and on a boat, then how far the boat's sailing is generally not as expensive. And one of the other things that this assumes is when you're shipping large quantities of gas on an annual basis. Whereas if you're, say in Victoria, if you're only looking to, or the southern states of Australia, where you're only looking at bringing in gas seasonally, and you're outside of the demand peak in North Asia, where during their during their summer is our winter, so they don't need as much LNG. So there's potentially idle capacity in terms of ships and idle production capacity. Then, some of the economics then stack up a bit more in terms of making the LNG import terminal argument a bit better. Obviously, a lot of those assumptions have been blown out of the water with the high LNG prices at the moment. Last one, finally, there is the Iona storage facility I mentioned down at Port Campbell. So it's actually, a very large facility, sort of 500, 600 TJs a day of supply. There is also another storage facility that's planned for near the Longford gas plant, the Golden Beach plant. So again, we're sort of seeing the potential and increasing interest in gas storage to again have that flexible supply. One of the key points with gas storage is you actually got to have somewhere, you've got to have a suitable reservoir underground. You can't just sort of dig a hole and put it in there. It needs a gas well. So that's the end of section 1. I'm not sure how I went for time, probably wiped it over, but
we'll have a quick break for questions, and there is some in the room and there is some online as well. So we might start in the room.
Right. Thanks, Matt. Quick one on supplies from Queensland, which is fairly topical at the moment. You showed some slides, increases on the Southwest Queensland pipeline and then on Moomba, Sydney.
Yep.
Is there any constraint on actual throughput of gas through Moomba itself? So can all the gas, if you were getting, forget number 430 TJs a day, could all that flow round Moomba into the southern pipeline? Yeah,
there are good question. Yeah. Oh, sorry. Okay. Yeah, sorry. So the question for online is, if with the increasing flows from Queensland on the Southwest Queensland pipeline and the Moomba City pipeline, can all that flow through Moomba? So it's not. I assume the question is it's not going through the Moomba plant. There are effectively compression stations and regulator stations at Moomba that'll manage the flows between the pipelines. So there are actually some big compressors at Moomba to send gas north. So sometimes the gas flows north. So yeah, big regulator stations and compressor stations there.
Hi, thanks. I was just wondering why you kept on saying that there'll be a requirement to increase gas supply when currently 72% of our gas that's extracted is shipped overseas.
Sorry, so the question about the requirement to increase gas supply, you mean?
Yeah.
Okay, so the question was around the requirement for gas supply when currently a lot of gas is exported overseas. So it's not. So it comes back to obviously most of the export gas is produced in Queensland. Where we're sort of looking for increased supply is being able to have more gas in southern Australia, where there is generally declining production. So that gas is coming from Queensland, particularly during the winter, but then you then get an issue where you cannot ship enough from Queensland because of the size of the pipelines. And maybe to put that into some context, is the flow to Curtis Island from the 3 LNG plants is around 4,000 terajoules a day. The pipeline capacity currently from Wallumbilla to Moomba, that Southwest Queensland pipeline, its capacity is 404. Okay, so you can get 10% of the Curtis Island flow through that pipeline. So it's not so much the lack of gas, it's the lack of hose pipe to get it down to the southern states.
One more from the room, and then I've got a couple online.
I've been here 28 years. I'm most interested in to find out which company currently AGL provide the best service. That means economical and good.
Okay, I can't comment on. So your question is what retailer is the best? Yeah, I can't comment. I can't comment.
Okay.
Thank you anyway. But, I'll just move on to a couple of questions that we had online here. One was around demand management and whether you could expand on the challenges there. That is it a problem of the rate of response or simply the ability of customers to vary their demand that restricts your ability to regulate the gas?
Yeah. Okay. I've actually, I'll cover that in part 2 around demand management, but probably one of the key things about gas demand management is you think, again, come back to your gas meter at home. It's a pipe outside, it's a meter, not really any smarts or intelligence there. Whereas in the gas system, you know, electricity system, you've generally got a smart meter, and the distributors can actually load shed and turn electricity off to big parts of the network. Whereas in gas, if you actually started cutting off the supply to the gas networks, you lose pressure in the gas networks, and then you can get air into the pipes, and that's quite unsafe. So there's quite a different dynamic and safety imperative in terms of keeping the gas supply on. And I think we'll cover that off a bit more in the next bit.
Well, I think we might just move on.
Cool.
The time. So I'll come back if there's time for more questions.
All right. Okay. So I'll go through this. Just going through the Victorian operations overview. So look, AEMO's got a number of roles in the operations system. We schedule the gas market. We actually operate the system, manage gas quality with emergency management. We plan. One of the big things we actually do is manage maintenance coordination. So make sure we don't actually have gas plants off at the same time. So again, there's a bit of work in that. And then, as I mentioned, we actually operate the markets and make sure there's the gas supply guarantee is, again, making sure there's gas for power generation. So that was something we activated for the first time last week. Probably just a little bit more detail, and I'll run through this very quickly. In terms of the Victorian system, on the right-hand side of the page, you've got all the offshore gas fields that supply into the Longford gas plant. And also you've got the Orbost gas plant as well. That's got a couple, the Sole field that flows into that. And on the left-hand side, you've got the offshore Port Campbell production, as well as the Iona storage. And that's actually, the Iona storage is actually built on top of an onshore gas field. You've got Melbourne in the middle. And as I mentioned in the other slides, you've then got the interconnector up to New South Wales through the middle, as well as you do have the Eastern Gas Pipeline that goes up the east coast to New South Wales. And finally, on the left, you've also got the pipeline to South Australia. As I mentioned, AEMO operates a Victorian system, which is actually fairly unique. There's actually, as prescribed in the national gas law, there's an agreement between AEMO and APA that covers our operation of the system called the Service Envelope Agreement. In terms of Victoria, I suppose a typical gas site. So one of the things I did mention before is at the Brooklyn site, which is in sort of inner southwest Melbourne, it's actually a bit of a key point where gas comes into the system, and there's compressors to take gas out of the system. Gas coming into the system comes in at very high pressure. And you know, for those that all know the Joule-Thomson effect for gas at high pressure, if you reduce that pressure, it gets very cold. So you actually have to have heaters, and then you have a whole bunch of taps, valves, regulator stations actually cut the pressure down. And then you've also got compressors to then compress that gas back out of the system for when we take it back down to the storage at Port Campbell to fill that during the summer. That looks like, in our control room, it looks like this, right? So we're not actually out there starting and stopping compressors. It's all done by data lines and electronics, and effectively this is how our control room interface with the system. In terms of, I'm just going to run through very, very quickly some of the toys that are in the system. So you've obviously got gas compressors. They're generally all centrifugal compressors with gas turbine engines, predominantly made by Solar Turbines, which is a subsidiary of Caterpillar. You also then have the regulator stations where that's actually controlling the pressure and actually letting the gas pressure down, and they're spread throughout the system. One of the other key points in the system is the Dandenong LNG facility. So there's actually a facility in Dandenong, which is where most of the gas in Melbourne comes through. Again, it's where all the gas from Longford comes from. We've got a small LNG tank relative to the export projects, where gas is actually scheduled and injected into the system during periods of very high demand, and we're unable to maintain pressure. And I'll sort of run through a little bit of an example of that soon. And also, there's actually maintenance operations that occur from time to time as well. So if you've got a new suburban connection coming in, so you're building a new subdivision outside of Melbourne, stuff like that, needs gas, they actually got to generally weld onto the pipelines and actually put in new connections. So that's got to be done under certain conditions and safely. And there's also inspection where they actually put what's called a pipeline inspection gauge, or a PIG for short, where you actually put the equipment inside the pipeline, and it actually flows through the pipeline and actually measures the thickness of the pipe and actually checks that it's safe. So, and as part of that inspection program, we then they do find damage. So there's a section of pipeline that found that somebody's not dialed before they dug. There's a dent in the pipe, and so it's got to be dug up and a sleeve put around that to make sure it's safe. And that's obviously going to be live welding on the pipe to do that, but that's again routine operation. In terms of Victorian demand, obviously you'll know yourself, during the summer we don't use a lot of gas. Bit of heating, bit of cooking, but we don't have the heater on. Whereas during the winter, there's actually a lot of demand. So you're sort of going from about 250 terajoules a day of demand during the summer, up to 1,200 or more during the winter. The other one too is that, look, even during the day, the demand moves around a lot, right? And generally the tariff D demand, the large commercial and industrial users are pretty flat during the day. They ease off at night. Some load is obviously all the time, but some are just business hours and then off. Whereas you've then got the residential load during winter, and that's obviously quite substantial. And then you've got the gas generation demand on top of that, and that can be quite variable. The other graph, which I think this is quite important, is how much gas does that Victoria use, and how much is that relative to electricity usage? It's like, some people go, we've built 2 solar farms and we've got the big battery, why we're still using gas, right? Whereas if you actually look at it this is from ENA using AEMO data, and it does back out power generation impacts, but during the summer, the gas and electricity consumption, the amount of energy used, is about the same, whereas during the winter, we use about twice the amount of energy as gas as we do electricity. And then to overlay that, you've also then got transportation. So, okay, if you're going to electrify all of that, okay, that's then the blue line. And then you've got the yellowy green line of where we are now. So that's a lot of energy to electrify. So it's going to be a bit of work. And look, the other one too is, okay, well, who uses gas, right? So a lot of, we did do some analysis. About 20% of that gas use is for chemical production, this building and construction materials, food and beverage. Some of that's easier to electrify than others, right? And that's going to be one of the challenges as well. And look, and that's also where some of the discussion around hydrogen comes in. But again, that's a discussion for another day. So a little bit of the Victorian system in terms of why the Victorian system's unique, but also why AEMO sort of effectively has the role that it has. So the system actually only holds about 450 to 500 terajoules of gas. That's what we call line pack, and probably only about half of that is what we can use. And that's because the supply facilities are only about 200 kilometres away from Melbourne. Whereas you think about Sydney and Adelaide, the gas supply lines that supply them are like 800 kilometres long, and there's 2 of them. And we also then have a very, very cold winter. So then to put that into perspective, we've got about 500 terajoules of demand in most of the other SCTM hubs. Well, actually not SCTM hubs. So like in Adelaide, you've got about 500 terajoules of demand, but most of that's power generation, right? The hub is probably 50 to 70 terajoules. Sydney, they've got a reasonable demand. There's power generation as well there. And Brisbane, Queensland area, again, a lot more power generation. Whereas Victoria, we can go to 1300. So the record day we've had is 1300. And it's actually, if you look at it relatively size-wise, it's quite small. So as I mentioned, you've got Sydney and Adelaide, got nice big pipelines supplying it. And we've got relatively small pipelines supplying Victoria. So instead of 2 or 4 days line pack in the system, we've got 2 or 4 hours. And that gets challenging to operate. And that's part of the reason we have that LNG tank we just showed you to manage high demands when that occurs. One of the other challenges you have, and again, it's probably getting heavily into engineering, so I'll stop after this, is when you're flowing gas from one point to another, you'll get a pressure drop, right? And you have a maximum and minimum pressure that you have on the pipeline. So you've actually got, line pack in between those arrows of how much gas you can, take out of the pipeline and still meet the minimum pressure at the left-hand side. Problem is when the flow increases, then the pressure drop increases, and so then my line pack reduces. So as I get more and more demand, I get less and less line pack I can use. So the system's acting against me. I've actually got more of a demand problem and more peakiness in my demand, because I've just mentioned before, the demand goes up and down during the day when people get up in the morning and cook at night. But I've got to store that gas, right? Because the gas comes into the system flat. So during the day, I've got times when the demand is more than what's coming in, and times when the demand is less. So I basically need some storage because otherwise I'm running out of gas. So what I'm doing is I'm then looking at, this is the line pack in the system. So during the morning, that's going to drop. During the day, that should increase. And during the evening, it'll fall away again. That'll stay above minimum pressures and it'll fill up again the next day. At least that's the plan. When we get into trouble is when that blue line stays above the green line all day and that purple line just keeps dropping, because actually it's really not a nice day and I'm just going to sit at home and it's raining and everybody just leaves their heaters on all day. So that's where we get to trouble, and that's where we come back to the 4-hourly scheduling of the market, where I can schedule in gas every 4 hours to get more and more gas in the system, and when I can take gas out of that LNG tank if I have to. So you probably don't need to be a rocket scientist to go, well, these are all the things that will make the demand increase. So if it's colder, if it's windy, obviously when it's windy and you get all the drafts through your house, that actually takes a lot of heat out of houses. So that's actually got a big impact. Sunshine hours actually has a big impact. So even looking at a day like today, this morning looked pretty ordinary, and you're going, well, the sun's forecast to come out. So, you take that into account when you forecast, but if the sun doesn't come out, then, okay, now suddenly the demand is going to be substantially higher. And that's what we've got to be able to respond to. And we have models of how the weather forecast behaving and how the demand is running against demand. So it's a running average model. And then we have databases of similar days and go, well, okay, last week or last month or 2 years ago, we had this sort of weather condition and this is what the weather did, and therefore we can feed that into our forecasting model. There's actually a reasonably linear demand. So below about 18 degrees, the heating demand picks up, and we actually call that an effective degree day. And there's a formula that then calculates the effective degree day. So, yeah, and it's generally pretty linear, but then there is also a fair bit of scatter. So it's a good guide, but effectively once we're getting down to about a 14.5, 15 EDD, then you can see the demand starting to get up to 1200 terajoules, which is a pretty cold day. We, during winter 2019 and 2020, we had a day each year that was 1200. So that was a day when you see snow out in Sunbury or up in Ballarat or in the Dandenongs. It's generally going to push the demand up. And basically for every degree average colder, the demand goes up by about 50 terajoules. So again, that's one of our challenges then is if the temperature ends up being about 2 degrees cooler than forecast, then I'm now looking at nearly 10% increase in demand. So one of the things, I'm just going to have a drink of water. So I'll run through a bit of a case study of then going, well, how do I know that I'm in trouble with the operation of the system, right? When I say we're in trouble, we're gonna have to do something, right? And we've got lots of tools at our disposal. But how do we know we're going to take some action? So we've got a demand forecast. We mentioned before we've got gas coming in and out of the system at the green circles. We've got this is a case study that's actually a day in November when it's actually quite hot and we've got a lot of power stations on. So we've got power stations scattered throughout the system. And then we're actually we've got system models, components of, I mentioned before, the regulator station. So we're actually flowing gas through the system and we're running compressors to move gas around the system. So gas is at the moment, in this case, going north and going down to Port Campbell to fill storage, and it's coming in from Longford on the right hand side of the screen. And we've got the LNG tank that we mentioned. That's the nice high flow point in Dandenong where all the gas is coming in. So we do have I mentioned before, we have a sort of system that's actually calculating the heating value. There's also a similar system that's actually looking at how much gas is coming into the system and what the pressures are going to do. So we bring all the demand forecast information, the schedules, actual flows, how we're running the system. We put it into a model, and the model then tells us what the pressures are going to do, whether we actually need to take action, whether we need to change the operation of the system, whether we need to intervene in the market. So back in 2017, it's probably it's a little while ago now, but it's probably one of the more dramatic days we had. The system was running normally, but pretty hot in Melbourne for end of November. But system demand is generally pretty low, right? We don't have a lot of heating demand outside of winter, so 300 terajoules. But a lot of gas generation, right? 191 TJs is, that's fair whack for that in terms of the total flow through the system. And then the NEM, the electricity market, is what's called an LOR2 condition. So that means if they lose one more generating unit, they're into load shedding in the power system. So that means that they're running pretty tight, right? So they want us to be a good, reliable source of gas for them. Because that helps keep the lights on. And they actually, under the electricity market, they have a process called RERT, or Reliability and Emergency Reserve Trader. So because they're in an LOR2 condition, they've actually already started taking action to bring in either additional supply or paying people to turn off. And the demand's going up. And then, obviously, like death and taxes, what can go wrong will go wrong, and we get the phone call from Longford to say we've got a problem. So how do we actually deal with that, and how do we work out how much of a problem we've got? So that's a little bit of the flow through the system, and I'm not going to run through too much, but we basically have a model, and we go, system's good. This is what the pressures are going to do in the system. No problem at all. Everything's above the red line. Okay, happy days. Okay, so 2 o'clock in the afternoon, we're now being told we're going to get a lot less flow out of Longford. So instead of 530, we're now 350. And those blue lines are not so good. That one's not so good. The rest are okay, but that's not going to work. So what we'll do is we'll play around with the operation system. We'll go, we'll stop moving gas away from Longford, and we'll keep it back in Melbourne to keep the power generation happy, right? So we talked about where the red dots are. That obviously, where we stop sending the gas to, those pressures will drop. Where we, but with the Longford end of the pipeline, that's gone up a bit. So still not good, but better. And again, we're just going through the arrows of, look, that's not going to work, right? We've tried to play around the system. We still can't keep pressures. So therefore, having just done a schedule at 2 o'clock, we then go, we have to intervene in the market. We have to do an ad hoc schedule, and we have to call in extra gas. So we then run some models to actually then work out how much extra gas we need. And then we'll run that through the models. And now with the green lines, we'll go, well, okay, based on it's basically an iterative process. We'll basically go, well, how much extra gas do we need? Pretty much a good starting point is, how much gas we've lost. We'll basically schedule that gas, and we'll go all green happy. Those flows are fine, right? So effectively, that's why we use the real-time model. So then go, we need to work out how to keep the pressure in the system and how to basically maintain supply. And also, it moderates our response, right? We don't sort of put in unnecessarily expensive gas if we don't need to. So, we didn't need to go to the Dandenong LNG tank to pull gas in. We're able to just organise flows from other points. So, gas generation supply is maintained. Market charges on the day were $265,000. So that's not too bad. I mentioned before, we talked about how the markets work, right? There's supply of gas, but there's also services. So this comes into a service where the markets pay to put in the extra gas, and then other parts of the market pay for that extra supply. And putting it into perspective, we did actually have an outage of the Longford plant back in 2016. They were offline for about 6 hours. That obviously needed a substantial intervention in the market as well to cover that, and that was like $3 million. So that was a big event, that one. And every time this happens, we have to write a report. So in a way, you go, well, okay, that's a sort of a bit of a combined market system operator type role. So that really comes into AEMO's, why AEMO exists, and our I suppose responsibilities and powers. So under the National Gas Law, we've got it sets out what our responsibilities are, and basically says we are responsible for the operation of the Victorian system. And one of the key power under that is we can issue directions to participants to maintain system security. So worst comes to worst, we say, you need to put this gas in, you need to stop doing this, and here's the paperwork, here's a direction. And that's, really being a statutory body, it gives us the capability to do that. And then under the rules, if need be, we can declare an emergency, we can issue threat notices for the system security, and we can manage interventions. And effectively, in terms of a hierarchy of response, we are trying to do a market response first, and then we, if need be, we'll intervene into the market, or we'll then curtail. And that's effectively our hierarchy of responses here, where market response or out of merit order gas at next schedule is considered normal operation. But if we go beyond that, we've actually have to write an intervention report for that, it's a bit more heavy-handed in terms of the operation of the system. All right, just rounding out. So in terms of, you know, emergency, so one of the things that is actually written into, you know, emergency processes in Victoria is a 5-level emergency level. So you've got a level 1 emergency where it's pretty low key, and level 2, it's an operational response. Level 3 is when you've basically got emergency services on site to deal with an issue. Level 4 is when you've actually now impacting multiple participants. So you've potentially got a transmission system that's then issue that's impacting a distribution network, or you've got multiple distribution networks got issues, or you've then up to level 5. So that's a major emergency. So obviously 1998, when the Longford plant was offline for 2 weeks, that was a level 5, right? And everybody's running out of gas. So we want to try not to go there. But that's effectively the orders. And obviously then in terms of your response, you manage it accordingly, right? So, you know, level 1 and 2 emergency or your high demand conditions, you generally manage that without any sort of, you know, further noise or engagement. Within level 3, you're starting to coordinate media and duty responses and the like. Once you get up to level 4 and 5, you are into, you know, potentially crisis management, but there's also actions like single industry spokespersons and stuff like that that'll stand up, and you're starting to get a lot of media messaging and engagement with the government. And finally, so you know, we do get a bit of a license to drive the transmission system, so we do actually have to have a gas safety case. So we are classified as a gas company under the Gas Safety Act. So we are required to submit a Gas Safety Act, and then within the National Gas Victoria Act, it does actually set out the requirement for emergency procedures and curtailment procedures. It's referred to as the emergency protocol. So that's it for how the transmission system works. So hopefully that's not gone too long.
Thank you, Matthew. I'll just swap sides because that microphone is
Excellent.
better. So there are a few questions online.
Yep.
I'll deal with those so we can finish the webinar, and then that's for So there are a range of questions which I won't ask that are related to policy, and we pointed out that AEMO is often forced into the policy area, but it's not a policy agency. So we'll keep those.
Yeah,
no,
I appreciate that. I was just saying, where you go back to the very early slide, we're the operator. We're the ones who deal with what we get.
So the other two questions that came up from a number of people, you mentioned line pack before as being a core part of the storage and the LNG facility.
Yep.
So two questions came up. One was, do you know how much gas is in the LNG facility of Dandenong? Is that within your remit to know that?
Oh, definitely.
And the second one is, what if we were to build more storage? Would we avoid many of the problems of the interconnection?
Yeah, okay, yeah, good question. So yes, we know how much gas is in the LNG facility. AEMO's actually contracted some emergency capacity in that facility. And look, there are some discussions around how much gas is held in that facility, because it is a pretty key facility. In terms of developing more storage, yes, correct. Developing more storage does help manage the supply and demand. The Iona storage facility does have some further expansion plans, but then that does mean that the pipeline from Port Campbell needs to be bigger, which is, you know, part of that pipeline expansion discussion I did cover off. So, you know, you do need some more infrastructure to be able to support that demand. And also I did mention you've got the Golden Beach facility potentially as another storage facility as well, but you know, you've got to actually have suitable places for, you know, to develop underground storage, or you know, LNG tanks are another option, but they're pretty expensive. There is one in Newcastle that AGL built, but you know, that is still an option as well.
Thank you. And the second question related, probably again, could be a simple answer. What if we simply insulated our homes better? How much would that reduce overall consumption? And the top line answer is a lot.
Yes.
But do you have a?
Look, honestly, I don't have data on insulating houses, but yeah, energy efficiency is certainly a key to reducing gas and electricity demand, right? So yes, that's important. Look, I don't really have figures. Probably the only thing I can offer is the general average amount of energy that a new home uses is noticeably lower. So we are seeing, you know, lower gas consumption per connection. But there's also one of the other things that distorts that is a lot of new sort of townhouse developments are putting in, say, gas hot water and gas cooking, but then they are using air conditioners, heat pumps for heating. So we are sort of seeing that as well. But yeah, I can't quantify the energy savings, but you know, probably, yeah, I won't put myself on the spot.
That's fine. Thank you. I think that that covered off the online, so we could stop the webinar. Thank you everyone online for participating and for your questions. And obviously we didn't have time to cover them all in detail, but hopefully have covered sufficient. So just stop the webinar.